So this is a touchy demonstration. This is a demonstration of supersaturated solution. Right now I have more grams of sodium acetate than I can possibly dissolve in this water. There's a little bit of water and a lot of sodium acetate. It looks like a lot of water, but this is actually a suspension of basically sodium acetate ions that want to crystallize. The water can't dissolve it, but because I heated this solution up and then let it cool gently, what we have is ions that are suspended but do not have any organization. As I have told you, we look at solubility curves for solids. And what do you get? You have the what? Grams of the solvent, which is static, and then we have the grams of the solute right here. Okay? So we have sodium acetate. Now, acetate actually is the conjugate base of vinegar. Now, vinegar is an organic acid. It's CH3, and you see this on your table sometimes. People say, what's that compound? CH3 bonded to a C, it's double bonded to an O, and this is vinegar right here, this OH. But as we're going to learn, this H is acidic, so it comes off as an H positive. That's why vinegar is a little bit acidic, right? And H positive comes off, and this is a negative, and this is the acetate ion. All right? That's why they call it acetic acid, the acetate. Now, they write it this way in your reference table, but they also write it another way. So they will write CH3, okay, COO. You've seen it that way. It's like, which one do I use? Well, one is showing how it bonds, and of course they write it this way also. C2, H3, O2, and it's -1. Why is it -1? Because it lost an H+. Okay, so this is the acetate ion, a pretty big molecule, but the whole thing is -1. So it wants to get in a crystalline structure with the sodium, because now we have sodium acetate. Sodium acetate is a salt. Na+ is +1, and of course we have the acetate here is -1. So sodium acetate, this is the formula we have. Now in water, it breaks apart into what? Na+ and our acetate ion. And the shape and size of this acetate ion makes it hard to get in the crystal arrangement. Now, what do I mean by crystal arrangement? Crystal arrangement, solids need to be in crystals. So it could be the positive here. This could be the negative here. This is the positive sodium here. Oh, I can't do that. That'd be the negative ion there because it's attracted to the positive. And this would be the positive here. So this is the crystal arrangement of, let's say, of a 1-to-1 crystal. Sodium plus, and the acetate ion. So the crystal wants to get in this arrangement, but because the temperature is low, the motion is low, these ions are just kind of jumbled up on each other. All they need is for me to arrange a crystal in this pattern. So what I'm going to do is I'm going to put some seed crystals. I'm going to put some sodium acetate solid on the bottom of this supersaturated solution. And I'm going to pour the solution onto this crystal. By pouring the solution onto the crystal, the solution is going to see an organized pattern there already. And what's it going to do is, as you pour on it, okay, which is pretty cool, because it's already organized, the ions are going to arrange themselves in a continuous crystal as you keep going. This would be negative here. Okay. And it's going to keep going because it's already started. So all it needs is a seed crystal. Now, before I do that, let's explain supersaturated one more time. I took sodium acetate, and I know that under high temperatures, its solubility curve is big. So let's say at, I don't know, 90 degrees Celsius, I'm making some numbers up here. Let's say I added, how many grams? Let's say I added, my line's not straight, 100 grams of sodium acetate in 100 grams of water. Now, of course, I have a much larger amount here, but what happens as it cools? So right here, I'm saturated. But as the solution cools, what happens to the solubility for solids as temperature drops? It decreases. So as the temperature drops, the ability of the water to dissolve it drops. And now, let's say at this temperature, whatever it might be for the room, around 20 or so, I still have that much stuff dissolved. So as it dropped, that much it cannot be dissolved at this temperature. So it's kind of sitting there Waiting to do what? What's the word when it comes out? Precipitates, waiting. So you watch me do the ones with the click where I made a sound and the compression wave pushed some molecules together. Now, hopefully, as I pour this, now if there's any crystals on the inside of this, it'll set it off. So we're going to see. So I'm going to try to pour this over some seed crystals. My hope is as I pour, a solid will appear. Okay? So I'm going to move this gently to the side because if it crystallizes as I move it, at least we can see that demo. So, just going to put a couple of salt crystals, sodium acetate crystals, and all I'm doing, and it's nothing more than a little bit of solid. And again, what's the solid doing? Solid is a what? It's an organized ion already, or organized bunch of ions in the shape that this wants to get into. So once I pour on it, it's already started so it can find its way. Now if I shake this vigorously, just by chance, some of the ions will find themselves and then the crystallization will occur. So without further frost, let's give this a try. Okay? I've been saying that all winter, but hey.
Oh, that's fine.
You notice it's going back into the beaker. You see it going back into the beaker?
Yeah. That's so cool.
Now I'm stuck. And you can see it going backwards. So I needed to add a little more water so I could have gotten a little more bigger of a tower. But you can see just by adding some organized what? What's that? What about the glass? So now it's a mess for me to clean up. I was hoping to pour all of it out, but again, it's touchy because if you can see the crystal pattern, if it's touchy because if it once it starts by just pouring, okay, you are moving ions together and they could actually find their organized pattern and it crystallizes. But sometimes I can get a nice tall tower. This one wasn't as great, but you still got the idea of the demo. Okay, all right, in any case.